We will not do the recap of entire course today because actually I have done the recap of first 4 chapters before the midterm. So if anything is still unclear from descriptive statistics and random, discrete and continuous sampling, then please go back, refer to the YouTube recording of the midterm recap. Because also the content of the exam will be 70% or 80%. We will focus on chapters 5 to 9. Yes, so that's why today we will only do chapters 5 to 9. And as I said, if there is any question, of course, if there is any question from the previous chapters, you can always ask me at the end when we have a Q&A. That will also adopt our agenda. So this was the agenda that was originally planned. Okay, still, if you have any question at any time, you are more than welcome to ask in class, to raise your hand or unmute yourself. The session will not be approximately 2.5 hours because we've eliminated more than half now. So it will take around 45 minutes to 1 hour and 15. We'll still have 2 parts. PowerPoint is available on the website. We will not have a break though, because we don't do breaks for the sessions which are shorter than 1 hour and 45 minutes. So let me start by chapter 5. So chapter 5, it's called sampling distribution, but chapter 5, there are only 2 important equations that you have to remember for hypothesis test and for confidence intervals. So we have multiple sampling options. So we have a simple random sample where we take the samples randomly, so there is no way of predicting who's going to be chosen in a sample. Really, it's just chosen randomly. On the other hand, systematic sample, as you see, we choose a system that we follow. So from in the population, for instance, in a list, we will choose every 5th member of the population, and that will be our sample. We have stratified samples, so it means we split the population in more divisions. So we split them in subgroups. They are known as stratas, and then from each strata we pick a part of a population. And the cluster method, it's similar, but here we have clusters which are classified. So we have, for instance, school districts. That could be an example of a cluster, and from this cluster we choose then our members of a sample. So we have 2 major equations: sampling distribution of a mean, sampling distribution of the proportion. So let's start by sampling distribution of an X bar. So X bar represents a mean. The most important equation two equations that you need to know. Basically, in reality, you will mostly need the second one. First one is that average of the sample is the average of the population. So it's perceived to be the average of the population, right? And standard deviation of the sample is a standard error. Standard error, as you know, will be used to calculate confidence interval and to test hypothesis. So the standard error of the population, on the other hand, is so the standard deviation of the sample divided by the square root of the number of n, so of number of answers or number of the sample size, actually. So n is the sample size, so we have the standard deviation which we calculate using the formula STDF dot S, so standard deviation of a sample, which we will then divide by a square root of the sample size. Then we have a central limit theorem, CLT, which will actually tell us if we can use distribution models that we know when speaking about confidence intervals or hypothesis testing. So the first one, so we have to first ask ourselves if the variable is normally distributed, right? So if the distribution is normal, we can conclude that in any case we can use the central limit, that we can use the standard distribution, so that the sampling distribution of the sample mean is also normal. So we use the normal distribution, right? If it's not, so so if the variable is not normally distributed, then we have to ask ourselves, is the sample size 30 or more? And it must be more than 30 to be able to use the sample to determine that the sample mean is normal. If it's less than 30, we cannot conclude and we cannot use the standard normal distribution. Then we have the sampling distribution of proportion. So proportion is a random variable, but we have to satisfy one more condition here. It's not only enough that we have 30 answers. We need to have at least 5 x's and at least 5 1 minus x's. So at least 5 p's and at least 5 1 minus p's, right? Plus the n must be more than 30. So for mean, well, we will once again say that our mean of the proportion is the mean of the population, and for standard error, it's calculated a bit differently. So we will calculate it as the square root of p times 1 minus p divided by n. So these two formulas, at the moment, they don't really tell a lot, but it will be much clearer now soon when we come to confidence intervals. So when we use the confidence intervals, we have 3 different options. So we have 2 confidence intervals for the mean and 1 confidence interval for proportion. So the first one that we will now see is when we know the standard deviation of the population. So this is the Z or the Z standard, the Z confidence interval. Why is it a Z confidence interval? Because we can use Z as an abbreviation for standard normal distribution. And in this case, we can use standard normal distribution straight away because we know the standard deviation, population standard deviation. In reality, this doesn't happen, but in some simulated cases it can. If nothing, so here we have a confidence level. The Z depends on the degree of confidence. If nothing is written in the exercise, we always perceive that the confidence level is 95%. Then we have alpha, which is significance level, which we will mostly use in our exercises, which is 1 minus confidence level. And we have to find the error margin as well. So the error margin will actually tell us how large is the confidence interval. So we can calculate error margin by multiplying Z, so the point, the limit point, by standard error, or we can also use the pre-calculated Excel formula where we only plug in significance level, the standard error of the population, and the sample size. What does this mean in reality? So first, I always suggest you also for the exam to prepare a pre-programmed Excel file, because it goes much easier then. So first of all, there are some spaces that need to be filled. So here we have the sample size, we have the standard deviation, which was given in this case because we are using the Z distribution. So standard deviation must be given. We have X bar, that's just an average of the sample, for instance, of the amount spent here, and we have a confidence level of 95, leading to the significance level of 5%. How did we calculate the Z? So, do you still remember? Let me use my pen. So, we have the standard normal distribution, right? So we want to determine, so for the formula, it's the norm as m, so normal standard distribution, and we want to get the point on the x-axis because we are doing an n. So we want to have a point, but because significance level is actually 5%, we need our confidence interval needs to leave 2.5% on each side of the slope, right? So we need 2.5% here, and we need 2.5% here. That's why we have to use the formula 1 minus significance level divided by 2. Because then our confidence interval will be, in this case, 95. Then it will take into consideration 95% of answers, or of amount spent, of answers given. Let's see. As I said, standard error, in this case, it is just the sigma. What is then the sigma? Sigma, we just tend to split the formula, right? So I'm sorry. So the sigma, in this case, so we have a 14, right? Because for standard error of a mean, you still remember what is the formula? Is the sigma of the sample divided by the square root of n, right? And that's what we have here. And then for the error margin would actually tell us this distance, right? This is what the error margin is about. So error margin will tell us how far in each direction from the X bar we have to go, okay? And then once we have the error margin, we can calculate the precision. We didn't really learn a meaning of a precision, so I just suggest you to know the formula in the case it would be needed. So it's error margin divided by the mean. But then what's the important is to be able to calculate lower level and upper level. So first we always take the X bar, and then we will subtract for the lower level, we will subtract an error margin. For the upper level, we will add, so we will sum the error margin and the X bar. So this is a bit nicer than I presented before. So we are searching for 0.025% of an area, as I said. That's why we got 1.96, because that is the point which represents 2.5% of area, right? If we had a 99% confidence level, right? Which point would it be? Would it be this one, or would it be that one? Audience in class, do you have any idea? Which point? Point A or point B for 99% confidence level? Anyone online?
It's A.
It's A, right? Because then what will be the size of this area if we have 99% confidence level instead of 95? Do you have any idea what will be the size of this area? So for a 95% confidence level, the size was 2.5%. So what would it be for 99%?
Isn't it 0.05?
Yes, 0.5%, right? Because we need to have 0.5 on each side then. So always remember this as that it appears on both sides when calculating, and then you should be able to not make any mistakes when calculating the confidence intervals. Then we have the other option. This is more common option when we have numerical data. When we have numerical data, but the standard deviation of the population is not given. We have to calculate the standard deviation of the population, but as a consequence, because the standard deviation of a population is not given, that means that instead of Z interval, we have to use T interval, which is a bit different. So what does really change here? So this is the fancy formula that probably no one understands by heart. So let's go slowly then. What do we do? So as you see, standard normal distribution is a bit different than the T distribution. So we have to calculate our interval using the T distribution. How do we calculate the T? We use the point T. You remember we had the point Z before, right? This one. Because the standard deviation of the population was given. Now it's not, so we can't have Z. We must have the T. And the T is calculated by T dot M to T. What does 2T means? It just means two tails, right? If you want to calculate T directly by using the significance level alpha, then you have to use this formula. Otherwise, you could also use only T in formula, but then you would have to do 1 minus alpha divided by 2, as we did before, remember? Because we have two tails that we have to check. But if we use the formula 2T, that's done. We can forget about it. The degree of freedom, do you remember? Can anyone remind me what the degree of freedom is when doing confidence intervals?
It's n-1.
Exactly. So I can see now that it's written here, so it shouldn't be too difficult, but it's actually n-1. We will see multiple degrees of freedom, right? Usually, when we speak about a sample, it's always n-1, but at the for the chi-square test, which will be our last topic to speak about, it will be different formula. But remember, for the confidence interval, n-1. To find the error margin, you still remember what an error margin is, right? Error margin is the distance. Do you remember error margin? This distance from the X bar to the critical point on each side. To find it, we use the difference formula. Now we use the confidence T. You remember which formula we used before? We used the confidence norm because we had normal distribution. Now we have T distribution, so we use this formula. This S is basically, you know, what's the difference between sigma, as we have here, and the S that we have here. Anyone knows the fancy difference between S and sigma? So the only, yeah. Anyone know? So the only fancy difference is that sigma is when the standard deviation is given and the S is when we have to use the formula standard deviation of a sample to calculate it. But at the end of the day, for us, it doesn't make much difference, right? So here we will just plug the same number. Actually, the calculated standard deviation of that we will calculate from the sample. We'll plug in alpha. You still remember what alpha is a significance level, and the sample size will be n once again. Then it's the last confidence intervals that we need to do. The last one, so the third one, these are the confidence intervals for proportions. So we have the three main parameters here. We have a p hat. P hat is a proportion measured in the sample. So p hat, for instance, if you have the sample of the EHL students liking the new pizza that they serve in Grab and Finger Food, and if out of 50 students, 40 like or let's say the sample size was 100, and out of 100 students, 90 of them like the pizza, then the p hat will be 90%, right? It's the positive divided by the sample size, n. And then we have 1 minus p hat. I hope it's clear. 1 minus p hat plus p always must be equal to 1 or 100%. Also, we have the conditional validity. We have a CLT, central limit theorem. I hope you remember it from before. N must be more than 30. P hat and 1 minus p hat, they have to be more than 5, as we see here. If we first focus on my terrible drawing skills, not so, but on the CLT. So what do you see? We actually first, before making calculations, we have to calculate, okay, CLT, is it more than 30? Yes. Okay, it's okay. We can go ahead. Is it less than 30? No. We have to stop at this moment because we can't calculate the confidence interval for proportions if CLT is less than 30. Also, the number of p hat more than 5 must be more than 5. Also, the other one must be more than 5. And then we can actually start. How do we start with? So first we prepare the upper part of the calculation. Upper part of the calculation, it's actually the sample size, p hat. You remember what's p hat with pizza and EHL students? What was the p hat there? Yes, 90%, exactly. And the 1 minus p hat, what was 1 minus p hat? Of course, the 10%. Confidence level, it is given. If confidence level is not given, we will use 95%. Significance level, it's 1 minus the confidence level. In this case, we will use Z distribution, so standard normal distribution once again. So do you still remember 196? Yeah. Good. So then I don't need to explain. So it's just the point, point on the x-axis of the standard normal distribution. Standard error. Okay, this is just nothing more scary than the formula we saw at the beginning. So this formula, if you still remember, this is the standard error of the population. So it's square root of p times 1 minus p divided by the sample size. Then when we have a standard error, we can calculate the error margin. Error margin is nothing else but the standard error times z point. In this case, 10%. What do we do when we have it? So we always take the p hat as a base. Do you remember before we used to take x bar, right? We used to take x bar as a point, a middle point. But now, because we don't have an x bar, because we have a quantitative or qualitative variable, sorry. So we have categorical variable. We don't have an x bar. So as our base, we will take the p hat. So here just a bit about precision and finding n. So precision in proportion, it's very simple. It's exactly the same as error margin. So as I told you, when p is known, then it's exactly the same as an error margin. Hypothesis testing is the next chapter that we will look at today. It's a way to generalize the whole population. We want to make a conclusion, and we have a conclusion at the sample level, but we want to see if this conclusion is applicable for the whole population, right? And this is called statistical inference. Yay. Okay, so first of all, we have to formulate the hypothesis, right? For every statistical test, we have to formulate two hypotheses. Hypothesis 1 will always be the base one, right? So will be as it is now. So now we perceive that the hotel room size does not affect room price because we don't know anything. So we perceive it like that, right? And the hypothesis 1 will be set to prove the opposite, right? So it's very important to set the H0 and the H1 correctly, because in a later phase that will be crucial to either confirm or reject H0 in favor of H1. So if we try to prove something, for instance, in this case, we will try to prove that the room size affects the room price, right? That's what we want to prove here. Then this will be always the H1. Okay? Because the null hypothesis, H0, represents the current belief in the situation. It's always refer to specific value of the population parameter, not the sample statistic, right? So at the moment, we don't know if hotel room size affects the room price. So we can say nothing about it, right? We can just say that it does not affect because we are not sure. And the alternative hypothesis is always H1, is the opposite of the null hypothesis and represent a research claim or specific interference you would like to prove, right? If you reject the null hypothesis, so if at the end we find, okay, no, null hypothesis, we reject. So what does it mean? That simply means that you have a statistical proof that the alternative hypothesis is correct and that you can confirm your research. But if you do not reject the null hypothesis, so if you cannot reject it, okay, that you have failed to prove the alternative hypothesis, right? But it does not mean that you have proven the null hypothesis. That's very tricky because last year's the exams for statistics, are always made in a way that you also have to understand what is happening behind it. So if you have failed to prove the alternative hypothesis, it doesn't mean that you have proven the null hypothesis. Okay? So p-value, that's the most important when speaking about hypothesis testing, because we have two different zones. So we have critical zone and we have acceptance zone. Okay? We will always have to calculate the alpha and the p-value, right? So the alpha will be our critical size, right? So it's the size of the confidence or in this case, the size of the significance level that we will speak about. For every statistical test, the criteria is always the same. We have to reject the p-value. We have to reject the H0, so the null hypothesis. In other words, when we reject the null hypothesis, we confirm the alternative. So we confirm our alternative hypothesis. Okay, and we do that when p-value is lower than significance level alpha. So p-value in this case, it's lower than alpha. It's in a critical zone, so we have to reject the H0. When the other, so if p-value is higher than alpha, it's in an acceptance zone, so we accept the H0, right? We have 3 types of tests. We have a right tail, left tail, and two-tail test for the right tail. So this is a hypothesis, hypothesis A, so hypothesis 0, right? The right tail test will always be the mean is higher than a value, right? So this is that's what we want to prove. H1, the mean is higher than the value. For the left tail, the mean is lower than the value, right? And for two-tail, we want to prove that P is not a value, but what will be the H0 hypothesis here will be simply that U equals the value here as well. Here will be, as well, in every case will be just that U equals the value, right? So these 3 sheets I won't really go to, but this is a pre-formatted data on how to work on the hypothesis testing. You just have to choose which one are we doing. We have 3 main ones. First one using normal distribution, using t-distribution, and using proportions. So it's always the same. So we use the normal distribution when the standard deviation of the population is given. We use the t-distribution when we have to calculate the standard deviation of a sample, and we use proportions when we have a qualitative variable, so categorical variable, right? Then the process for the normal distribution, it's just to calculate the z-calc and z-crit. You have actually the 2 options, right? First one is z-calc, z-crit. So we accept the H0 when z-calc is higher than z-crit, right? For the left tail. For the right tail, the opposite, and for the two tails, when the absolute of z-calc is lower than z-crit. But I suggest that the most important is to recognize which distribution is used. So for T and Z, it's quite easy. It's just if it's given, if it's the standard deviation of the population is given. But for the proportions, it's also easy to recognize it because you have a categorical variable. Then you look at this one, you see what you want to prove, and then you choose the right one, and then you just follow the formula for the p-value. So norm as this of z-calc, right, divided by 1, and you accept it if p-value is higher than the significance level. So then we will move on to simple linear regression. We have 2 regressions that we will see today, 3 regressions, sorry. Goal of the regression is to be able to make predictions based on past data. So we have a least square criterion, which is the base of the simple and of every regression actually, because this will give us our R square, right? When we do the regression, right? When we write a linear function, so we will have different points, right? At first, and yeah, you can see it. So this graph will be made on the least squares criterion. I don't know, it's nothing else than last topic of math course from Bosquan. I think you should all remember it. It's not that important because when you do it in Excel, you just do show the trend line and show the trend line equation. So it's done a bit differently, but that's just the understanding behind. For the t-test for the relationship, it always has the same hypothesis, right? So hypothesis one, there is no slope, so no relationship. Hypothesis one, that you want to prove that there is a slope which is not biased, so there is a relationship. And decision rules is once again very simple. You accept H0 if p-value is higher than significance level. We'll see where you can see the p-value. You have a few steps on doing the simple linear regression, right? So first of all, we have to determine the independent and dependent variables. We have to gather the data, but let me tell you, in the exam, we will not do the data analysis because the data analysis will be given, right? So we will start here at step 5. We will have to check required conditions. First of all, we have to verify the residual plot and confirm the normal distribution. So what does this mean? It means that we don't want to have any shape that would that would look as some kind of pattern. So in the residual plot, we don't want any patterns, right? We have to check the deviation from trend line, that's R square. The closer to 100, the better it is. And we have to also check the p-value of all of x variable, or of all x variables that I will show you later. Basically, the best is to show this on the example. Then we have outliers. We will always have to remove the outliers for the regression, right? The rule is we use it standardized residuals, and we have to eliminate all samples which has less than -3 or more than 3. They are outliers, and we will have to remove them because they violate our model assumption. So for the multiple linear regression, it just, again, the goal is to be able to make predictions, but they are based on multiple factors. So we will have multiple factors. First of all, we will have regression model, right? We have two hypotheses once again, and the accept decision rule is once again it's the same, right? For the relationship of each independent variable, right? So I will show this in the example, will be the best then, but here we only last thing is that we also have the f-test for the relationship. If we have no outliers, if we have good residual plot, then we can move on to the f-test for the relationship. And the f-test of the relationship is for the H1 is that all betas are equal to 0, and the H1 is that at least one beta is not equal to 0. If so, decision rule is simple. If p-value is higher than significance level, we will accept it once again. But now it's much better to show this here. So what do you look when you open a regression output? That's what will be in the exam. So first, we will look at the adjusted R square, right? Adjusted R square, in case of multiple regression, we have to look at it to comment the quality of the model. So if it's close to 0, the quality of the model is bad. If it's close to 100, the quality of the model is good. We'll also look at the significance F, just to remember if p-value, so if this value is lower than 5%, there is a relationship between X and between Y and axis, right? There is a relationship. Then we will also have to look at the all p-values. So this will be the t-test for the relationship. Each p-value has to be compared with 5% significance level, and it has to be eliminated if it's more than 5%. So in this case, we can see that the age of the apartment does not influence the price. So that's why if we want to have a good model, a reliable model, we have to disregard the age. We will have to exclude the age and make another regression without it. It's once again, we will start in the exam from step 2 on. So you will have to do analysis that I showed here. So first, adjusted S-curve, significance F, p-value, coefficient, and the residual plot, which will be given either as a graph or as a standardized residual. Then we also have a dummy variables. The dummy variables, they are nothing else but the categorical variables that we want to include in our analysis. So when we do, how do we deal with dummy variables? First of all, we have a simple dummy variable. So the simple dummy variable is, for example, view on the La Clément. It's just yes or no. But because we cannot plug yes and no in the computers, we will use 1 for yes and 0 as a no. We actually will have to code it. But because we all had the Python course of coding this semester, I'm sure that you are now all specialists in coding, so that will not represent any issue, right? So we will have to use the formula if lake view equals to yes, the output will be 1. If not, the output will be 0, right? And then we will have only one option here, right? Because it can only be 1 or 0. So what do we do once again? Let's see. First of all, when you have in front of you, you have a summary output of a regression, you will check the adjusted R-square. If it's close to 100, you have a good model. If it's close to 0, you have a bad model. Then you look at significance F, it has to be lower than 5%. In this case, it's good. We don't have a residual plot here, but you always also have to check for the outliers. Then you check the p-values. Okay, all p-values are less than 5%. That's a good indicator. We are good to go. But what does this coefficient mean, actually? Here, I think the data is given in the thousands. Yes, exactly. So what does it mean? So what is the difference in price for the apartment with lake view and without the lake view? Anyone? Yes.
Price increase.
Yes, it's the 18,219 francs, exactly, because this 18.219 is just, it's given in thousands is usually, but that just means that on that apartments with lake view are on average 18,219 francs more expensive than the ones without the lake view, right? Yes, so we have some data that I collected here for the multiple dummy variables, right? So we cannot code them if we have multiple dummy variables as here. So ClubMed 1, Catering 2, Bodyguard 3. We cannot code them like this. We will have to code them as 1 and 0, but we only code the n-1. You see that we didn't code the Bodyguard for private clients because that one is already included in the intercept, right? Yeah, you see. So because if someone, you can't be Catering and Bodyguard. So if you are just a Bodyguard, you are not Club Med, you are not Catering. You're the Bodyguard, right? And now I have a question. who earns the most, bodyguard, catering, or Club Med? Who out of these three, according to the coefficients, who earned the most money? Any ideas online? Okay, so this is your base intercept, 2, 4, 1, 2, right? This will be the intercept for bodyguard, for everyone, right? Because everyone has 1 times the intercept. So if you want to see the Club Med, the difference between the salary of bodyguard and Club Med, we have to do 2, 4, 1, 2 minus the intercept 1, 0, 3, 0, right? And that will be the difference in salary. So we can see that the bodyguards, they earn 1,030 francs on average more than the Club Med, and vice versa. We can also find that they earn 470 Swiss francs more than catering. Okay, can you spot the outliers? Do you see any outliers here? Yes. This one's?
Yeah.
So actually, how do you see the outlier? I think it's pretty clear to see the outliers, but it's also something more interesting in this picture. It's the pattern, right? We said before that on the residual plot, we don't want to see any patterns, but here we have a pattern, and this pattern is just because of the outliers. So in this case, we can practically see how important it is to eliminate the outliers, right? Because when we eliminate the outliers, we don't have any pattern anymore, and residual is good to go for the further analysis, right? So that's why it's so important to see the outliers. Okay, and we came to our last topic. As I said today, not a long session because we are just doing the chapters for which one new. So chi-square test, we have the two options, right? We will always use it to describe a population of a nominal variable, so qualitative, right? Categorical variable, if that rings a bell for you. We have a first test for a relationship between two categorical variables, and the test for a distribution, so goodness of fit for one categorical variable. Let me remind you that this one it is not required to know how to run it for the exam. This one it is. So for this one, you only need to know the theoretical aspect. They might ask something from the theoretical aspect, but it will not be, the calculation is not required for the exam. So let's see the example. Test of independence, right? We have a chi distribution. That's the third distribution that we see. We saw Z distribution, standard normal, that's Z. We saw T distribution, which we use when the standard deviation of the population is unknown. And now we have a chi distribution, right? So H0 will be that the two variables are independent. H1 will be that the two variables are not independent. We always check the conditional validity first. The total frequency should be reasonably high. So let's say the 50 is the number that, if it's lower than 50, we can't run it. And then we will follow some basic steps. I prepared an example. So this one is just for goodness of fit. Only thing you need to know about the goodness of fit is the H1 at 0 and H1, right? So H0 is that the population follows a probability distribution to be tested, and the H1 is that it doesn't follow a probability distribution, right? So you accept H1 when p-value is higher than significance level, or when xcalc is lower than xcrit. Why is that so? That's what I prefer to explain on the example. So this is the chi-2 test for the independence. That's the one that you have to know to run it and to explain it. First of all, we have the actual data. And I promised you before that there will be one more formula to calculate the degree of freedom, right? So the degree of freedom in this case, it's count A of X times count A of Y, and we minus 1 for each X, right? And then we formulate the H0 and H1. So for this independence test, it's always they are independent, and the other one, they are dependent, so not independent. And we will do the test of independence. The second thing is that we will need to determine the predicted distribution or expected distribution, right? How do we do it? We take the marginal probabilities. So to calculate this one, we will take 35 times 34 divided by the n, by total, so by 100. And once we have one formula, we can just drag it down and across if we log the correct cells. But then be careful to do the sums again. Now we have an actual data and expected data. Now we could already use the formula chi-square test, which has two arguments, the actual and the expected distribution. So now you can already calculate the p-value. Okay, so if they only ask you for which hypothesis do you take, so if it's dependent or independent, that's enough. You have two steps. You use the formula, you have a p-value. If it's lower than significance level, as it is now, right? What did we say? When it's lower than significance level, we accept H1, so we reject HO. So that means that the variables are dependent. But we can also be asked for xcalc and xcrit, right? Because that's the second way of determining the fit. Xcalc is nothing else but the sum of the cells here. So how do you get this? This cell is the first one, so the actual minus expected squared divided by expected. Okay, if you look at the example in Excel sheet, that should be really clear. And then for the calc, you just sum this one. For the crit is always connected to the distribution. We have chi-square distribution here. We want the inverse point, that's inf is point on the x-axis, right? So we will get one here, not difficult. Then we use this formula RT, or we can use the regular formula which goes from the left side. You just have to be careful. If you use the normal formula, just the chi-square inf, it's 95% because you will have 95% here. If you use the right tail one, it's just 5% because on the right side it's just 5% of the sample. And then we analyze the results. So in this case, our calc is higher than our crit, and our p-value is lower than alpha, right? So we accept H0 if p-value is higher than significance level, bless you. And in this case, we see that we accept H1, we reject H0, so the variables are dependent. Okay? And that also concludes our general recap of today. So, do we have any questions in the classroom or online? You have a question? In the chat, maybe. No, nothing in the chat. Nope. Any question?
I wanted to double check something.
Yes.
for precision, going back to chapter 6, I think. If the average is known, you do EM divided by the average. But if no average is given, it's the same as the error of margin.
No, for proportions is the same as error margin. For mean, it will always be error margin divided by mean because we have a mean, and for proportions we do not have a mean. Do you see it?
Yeah.
That's why it's the difference.
Okay. Thank you.
You're very welcome. Any other questions? Okay, all good. Then let me conclude this third session of EHL recap for BOSC 2. And let me also use this moment to invite you for our big EHL recap day the next Friday, when we will have 2 sessions. So put this in your calendar at 12:30, hospitality economics, extremely useful session before the exam. And at 5:30, the revision of service quality and design. So you are more than welcome to attend it. Don't forget, hospitality economics will be held in classroom. So sign up on the Instagram and come to classroom. If you're on campus, we will be more than happy to have you here. I think for the hospitality economics, the whole session it will take around 2 hours, for SQD around 1 hour and a half. So we're really looking forward to see you there. Also, if you need any material that was used in today's session, our website or the chat of this meeting, the recording of this session will also be posted right now on YouTube. If you are interested in any topic that we didn't do